Hi everybody, my name is Muchwana. So let's get started. So my name is Muchwana, like I say. This question comes from one of the students of knowledge from place in South Africa called Pretoria, Centurion, by Maseho Maha. She's from Centurion, so she sent me this question. She want me to help her. But this question here, you won't be able to answer this question if you don't have information from the computer, from the chemist laboratory. You see, I do a lot of coding, so sometimes mine is thinking about computer all the time. Okay, never mind me. So now let's just go back here first and see. Let's just go back and read a little bit, okay, how the practice is about. So I want to try to spend 10 minutes to solve all the questions. A lot of questions actually. That one right here, this one right here, there's another question, so we have to answer all these questions, okay? So from the experiment 3, they say anions. What is anion? Anions, okay, if you have a compound, either compound or radical with a negative ions, those we call anions. For example, sulfur dioxide is anions. See what I'm saying? Or we say sulfur dioxide, sulfate. See? So this is anions because it has a negative ions. It has a negative ions. Okay, let me say this first. Something with a negative ions, you call it what? Anions. 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 Okay? But something with a positive ions, for example, these are we call them cations or cations. They have what? Positive ions. But for now, we don't want to focus on cations. We just want to focus on anions. Okay? So we say anions is either could be element or compound or radical. I mean radical. These are radical. Some of them are radical. Like, what is a radical? Let me just show you back a little bit here. So radical, you memorize sometime. Most of these article, all of them. Just memorize. You need to know all of this in your head. See? So these are radicals just want to put together so you can either copy or try to put the link below. If you want, you can let me know. See? So these are radicals you memorize. For example, this ammonium, nitrate. You memorize them. Okay? All these are radicals, so you memorize. So this one here is cations. The first one is cations because it has a positive ions. This one is anions because it has a negative. So the one with the negative ions, we call it what? Anions. So ions, these negative, positive, these are, we call them what? Ions. You'll write bigger here, ions. But these ions have got two groups. Some of them, they are positive and some of them are negative. So the positive one, we call them what? Cations. Cations, the positive one, we call them cations. And the negative ones, we call them what? Anions. So for now, we're only going to focus on anions. We're not going to focus on cations or cations. Okay, for example, the first one, this is ammonium. You memorize the way how it is. Nitrate. And this is, you see, nitrate. Okay, now you see this nitrite. Nitrite means it's NO2, negative is 2. But a nitrate means there's a 3 here. NO3 negative. All of them try to memorize, please. Okay? So that's not my job to memorize here, but you should memorize. Okay? Now we go. So memorize all of them. So now, so how are they going to ask, for example, an exam? If somebody asks, for example, let's say calcium and oxide. So calcium hydroxide. Hydroxide is a radical, which has a negative. See, it has a negative. So this we call what? We call it what? Anions because it has a negative. Anions, okay? But calcium, it has a valence of 2. How you know? You can simply go to your periodic table here. You say calcium is here. So calcium is here. See, where the calcium? This is a calcium. So it's in a second group, and second group has a what? Has a positive 2. See what I'm saying? So then you can say, oh, okay. So now, if I had to react these two here, what I'm gonna do? These two is gonna come. Look, let's marry them together. It's gonna be calcium hydroxide. But I take this valence here, put below, and take this one. But I don't involve this the sign if it's positive or negative. Take these two here, and then remember, if somebody say negative means it's negative 1. If somebody say negative means it's negative 1. If somebody say positive means positive 1. So here means it's 1, even though it's negative, but it's negative 1. So take this number here. But if somebody say 1 spoon, you don't have to say 1 spoon. You can simply say spoon. So I don't have to write 1 here. So that's why you got calcium hydroxide, for example. You understand? Okay, if somebody say, so that's how you do reaction with something with a radical. For example, somebody say aluminum nitrate. So aluminum is going to react with a nitrate. If you come nitrate, it has is a anions because it has a -1. So it's -1, and aluminum has a +3. How you know that? If you go to the periodic table, aluminum is in a third group, is here. So this first group has a valence of 1 positive, okay, and this second group has a valence of 2, and then this third group means it has a valence of +3. These are transitional metal. Most of them, or all of them, they has a valence of +2. They are transitional metal. They have valence of 2, but some they have a 3, some they have however they have. So they say, oh, you say 2, what about silver? Yes, I know silver, it has a valence of 1, but most of them, not all, most of them they have a +2, but not all. Like silver it has a 1. So aluminum, for this case, it has a valence of 3 because in group 1, this group 3, this group 1, group 2, group 3. Ignore this one for now. This is a transitional metal. So aluminum is in a +3. Okay, so now we're going to say if you react these two, what happened? Remember, this is just a 1, so it's going to be aluminum bracket and then write your nitrate here. Take the valence of aluminum. That's why I say aluminum chose 3 because it's from the group 3 right here, and then this is just a -1, which is 1. So when you write here, don't write the negative or positive. See here, I didn't write the sign, I just write my 3 under and then my 1 under, but a 1 will say take out that 1, so it's aluminum nitrate. You see what I'm saying? So that's how you do. You can take any metal and react with any of these radicals. So now if I talk about radical, then you understand a little bit, okay? And how to react metal in any radical. Now let's go back here to our what we started here. We say, well, so anions, now we know anions means something with it. If I say something, then it's like I'm talking to my friend, okay? It could be a radical, an element with a negative ions, okay, with the negative ions, and we call it what? Anions, because of the negative. But for positive, we call cations. Okay, now we go. So that's what they say. This experiment about the what? Anion analysis. You want to analyze what? Anions. You will receive a mixture which has a combination of any of the following. Oh, so the mixture they're going to give to us, okay, take this, is a certain mixture, but that mixture is going to have a combination maybe of carbonate or sulfate or chloride or iodine or nitrate. That mixture we're going to have. So they say example of anions. Why we say anions? Because all of these have a negative ions. Look at this. This is a carbonate. Like I said, go to your radical, you see, excuse me, it has a yeah, you see, O3. This is a carbonate, you see. So the mixer is going to have a combination of anions, okay? Sulfur dioxide, this is SO3 -2. All these are in a radical. Like I said, you can find all of these, okay? This is pure, and then SO sulfate, you see. So the mixer is going to have a combination of this. For example, I'm just saying, somebody might give you sodium and sulfate. So now you need to know the valence. What is the valence of sulfate? You can just go to radical, you're going to see this. It has a -2. And sodium, it has a +1 because sodium is the element, and you can find the periodic table right here. Sodium is here. So sodium is this. It's in a group 1, means the valence of sodium is +1, means sodium +1. And now if you go to the other one is sulfate, right? Sulfate SO4. Okay, sulfate SO4, it has a valence of -2. Look, this one here. So SO4, yeah, it has a -2. And if it has a SO, it's like S4 -2. It's called what? Sulfate. But if sulfite, it has a 3. Remember, the sulfite, it has a 3, like SO3 -2 sulfite. Okay. So let me not deviate. Let's go and answer those practical. But at some time, I want to make sure like you're also in the same page and you know how to balance this question, because that's what we're going to be doing right now very soon. Now, so all these are anions because most of them, or not most, all of them, they have a negative what? Ions. They have a negative what? Ions. So anything in the negative ions is called anions. Okay. Now let's go now. Continue this one. So they're going to provide us with a oh, I didn't finish here, so remember we're going to take this 2 here. It's going to be N, A, 2, and this is just 1 is going to come after me. So put your bracket for S. So they might give you, no, there's no 2 here, sorry, it's just 1, because this 1 come here, so you don't have to write 1. So this is sodium sulfate. See, for example, means this, it could be a mixer which has a what? Has a anions. But now let's do what they ask us. For example, they say here anions divided into 4 groups according to the specific reaction that identification test. So see which one, the properties, like how they say these are properties. They could give you that one, that one, that one. Okay, and they say you're going to receive the mix of any of the following. Means your mixer could have this, your mixer could have this, or that, or that. Now let's go. Now these are apparatus that you're gonna need chemical. They say they might give you dilute sulfuric acid or concentrated sulfuric acid. Okay, you have a dilute nitric acid, and this is nitric acid. Okay, now nitric acid is NH3. See, so you should know that nitric acid. That's a nitric acid. You can memorize it. But for me, I know how this came about, because look, nitrate is a radical, and hydrogen it's just an element, but element in a phase group. So since it's a phase group, it's going to be positive, and this is going to have a negative because it's just a radical. So you memorize like the NO3. So if you put them together, it's going to be hydrogen. This one is going to come here, and this one is going to come here. So you don't have to write this one. So that's how the nitric acid come. Okay, now let's stick to what we want to do, because we don't want to go out of the way. This now by balancing the equation. I believe now you have an idea how to do that. Okay, so for example here they say calcium hydroxide. Look, they might give to you this miss. Look, why do they write calcium O2? Because calcium is in a second group, means positive 2, and hydroxide we know is a radical. So what happened is, and you can go and check in your periodic table why we say calcium has a 2, because calcium is the metal. Calcium is the metal. We finish now. As long as you understand this is the key things here to balance. Okay, so calcium is the metal. Look, this is calcium here. So you see in the group 2, so group 2 has a positive valence. This is the metal, positive 1 valence, positive 2, positive 3, and then here, and then you go to 3. This, it can be either 2, either can be done metal, and then you go straight from the right, 0, -1, -2, -3, but this can be either positive or negative, for it depends who he married with or she married with. Okay, now we go back here to our mission. So we know calcium is in the second group, that's why it's positive 2, and then hydroxide is the radical. You can simply get that in a radical here, hydroxide, like how we see. So you need to have this. Okay, hydroxide has a negative. So just want to show you how this comes about, or how you have. Look, so now you can simply cross this is like a 1. Like I said, don't worry about the sign. It's going to be calcium. 1 is going to come here, but don't write the 1. So hydroxide, and this 2 is going to come here, but we don't write 1 when there's a 1. Don't write 1. So it's calcium hydroxide. That's what we say, calcium hydroxide. You see what I'm saying? So it can change all the time. For example, okay, I don't want to go out. Let's just focus on that. Okay, so now they say nitrate. So you're going to have all of these apparatus. You're going to need all these apparatus. You can simply read. Now let's go to the second part. Okay, let's go to the next page. So for the next page here, let's read. So there's some let me show you some. So now what happened is, all these you're gonna need. You see what I'm saying? All these you're gonna need: concentrated nitric acid and all the anions. Now let's go to the next page. Now next page, they say here, okay, so when they provide us an anion mixer, which you don't know for now, like, okay, take this mixer, oh, okay, but that mixer is going to have anions which was there on the list, okay, the one that I show you. I mean, these anions, it could be that compound is going to have a mixer with something with it, anions that you don't know, okay. And then what happened then? They say now you're going to receive And they say weight 2 gram sample. So take a stuff, put in a balance, and then measure. Oh, it's 2 grams. And then what happened? Put in a weighing pot and dissolve in 30 liters of water. Take that, you see. But remember, you're gonna have your glassware, like let's say conical flask or graduated flask. So make sure you measure. What you measure 30 what milliliter of water, and then take the sample they gave to you, and then you're gonna put in here, which is what 2 grams, and then we're gonna dissolve 2 grams. Come and dissolve here 2 grams, and then what happened then? So and then after, filter if there's any solid. So when you dissolve here, remember something's gonna dissolve, but it may happen in a situation whereby you may have some solid. So try to filter and then separate the two. Okay, now let's do test one. Test one, they say in a test tube. Okay, we want to test what? Test for carbonate ions. Oh, so we want to test for carbonate ions. Okay, carbonate what? Ions, which is C3. Sorry, C. Okay, now how are we going to do that? Now let's see now how we're going to do it. They say pour 5 milliliter of saturated calcium hydroxide. So we know this must have a 2 here, even if they didn't write, because calcium and hydroxide, calcium has a valence 2, so 2 is going to come here. This is going to be -1, -1 come here. So this calcium oxide, hydroxide, even if they didn't write, must be there. Or you can take barium oxide, Ba oxide. Okay, let's take Ba. If it was written in a good order, or they make some mistakes sometimes, you know. Okay, now let's go for Ba, barium. Ba. Sorry. It has valence of 2. Yeah, it must be 2 because it's 2 here. Yeah, Ba. See, this is a valence of 1, this is valence 2 here, group 2. So even though they write like that, but I think in my opinion it's supposed to be right here. Okay, it's supposed to be as a barium, because in a group 2 barium and oxide, or you can take this. But we saw it's in group 2, means 2 is going to come here, and this oxide, you remember, is negative, so negative is not going to affect anything. Okay, excuse me, sorry. So now we say, let's continue the mission. So we can take 5 milliliter. You know, you can use your glassware and measure 5 milliliter, and then they say of either 2, and then into the test tube, put in the test tube, and filter the solution. You understand what I'm saying? And filter the solution. So this is how we're gonna do the test 1. Okay, test 1. So the first thing they say, anion mixture known. Okay, they give an anion mixture known, and then 2 kilograms. In a wetting pot, dissolve in 30 milliliter of water. Filter if there's any solid. Stop. Okay. Next step, or another one. Let's say test 1. We want to do test 1. Test 1. We want to test what for carbon? CO3 -2. Okay. Carbonate. You call it carbonate. Carbonate ions. Okay, it's also radical. Okay, so you can simply go to the radical, but at the anions one. Okay, so how are we going to do that? So let's say here, either you can take calcium hydroxide or barium oxide, and then filter the solution if necessary. It must be very clear. The next thing is, to another test tube, add 5 millimeter of anion solution, which is a known. Oh, so now remember you had this stuff here that you filter very well, but we don't know which anions is there. The second one, we take calcium hydroxide, or you can take barium hydroxide, and then what we're going to do, we say here, filter if necessary, but they did not say whatever, pour. So remember, this is going to be in aqueous form, means you pour it in another measuring flask or whatever, and they say, oh, it's 5 milliliter. Measure 5 milliliter, and then after that, okay, filter, and then after filter, and then they say add to another test tube. Take another test tube, no, of anion which you don't know. Use a test tube for this, For this, use a test tube, we can see. You see, for 9 we don't know, and then add hydrochloric acid. Oh, we're gonna add hydrochloric acid, and then what happened? Okay, now let's see what's gonna happen here. Now, then add hydrochloric acid to the anion solution. Immediately, stop with the finger like, and then insert the pipette and extract some gases. You think which gas is going to be formed? Look here, they even give you this. This is the, I'll show you now, okay? So, and then the gas must pass through the calcium hydroxide. So they decided to take for them calcium hydroxide. So the gas is going to pass through what? The calcium hydroxide. Now let's see what's happened in the chemical formula. So we're going to say here, look, there is going to be some milky solution which is going to indicate what? Carbon ions. Look, so at phase, remember you had what? Okay, at phase, take your carbon anions and then react with the sulfuric acid, and then you're going to have a carbon dioxide and water and chloride ion. Okay, you can memorize that. And then slide, and then you see, take this carbon dioxide, which is this, and then pass it through the calcium hydroxide aqueous, and then you're going to have a calcium carbonate, and then in water. See, in water. Now let's go next page. Now let's go next page. Okay, so that's experiment 1. Now the experiment number 2. Experiment in a new clean test tube. Now take a new test tube, and then we want to test for sulfate ion. So for the first one, we were testing for carbonate anions. In carbonate, this is carbonate. We were testing for that. But now we want to test for. So somebody said, "Oh, may I understand how this comes about?" Look, you can see here. So my power. See, we had a carbonate, and then we add hydrochloric acid, and then we get carbon dioxide, water, and chloride ion. And then now you take these carbon dioxide and then you react to the calcium. Okay, another thing here they forgot here. Excuse me. This question is not sufficient here. Look, it's supposed to be carbon dioxide for the second one plus calcium. Remember, this must have a 2, even though they don't write a mistake, because this 2 must come here. Remember, copper. You know how I did this. Calcium, like I did previous, it has a 2 is going to come here. Hydroxide has a 1 came here, so no change. And then we say this gonna give us this calcium, and it's going to be calcium, and then it's going to form carbonate. Means this is CO2. One of hydrogen is going to come and add here. Look, there is how many oxygen? 2 oxygen. So 1 oxygen is going to come here. It's going to form carbonate, and then we're going to plus. Remember, 1 oxygen went here, so we'll be left with H2O. So now we want to balance our equation to see if it's balanced. Now let's start with oxygen. How many oxygen? Look, 2, because remember, look, 1 times 2, 2, and it's going to be 4. Now let's come here, 3, 4. Okay, perfect. Carbon, let's go calcium. 1 calcium, 1 calcium. Now let's go for oxygen. 2, 4. All we did, which is 3, 4. Okay. Hydrogen 2 and hydrogen 2. Okay, so it's balanced. Okay, there was no mistake. Only this question here is supposed to have a 2 here. OH in bracket 2. Okay, now let's come here. No. For the second one now, we want to produce. Okay, we want to test for what? For sulfate ions. Now, you can just follow all this instruction. Add 5 millimeters of anion solution in test tube. So we don't know, let's assume. So we want to test for it, and then pour hydrochloric acid. So we pour hydrochloric acid on it to this part. So there's a question why we pour hydrochloric acid. I'll explain to you later. Okay, filter if necessary, and then add 3 drops of barium chloride. Look, barium chloride. So chloride, it has a -1 valence, but barium has a 2. If you cross these, look, 1 is going to come here, and this 2 is going to come here. It's going to be chloride 2. Excuse me, my Paul. That's why when you write barium chloride, say barium chloride like that. See what I'm saying? I'm going ahead of the, see, now we come here, add 3 drops of barium chloride solution to the, oh my god, my computer is freezing. Sorry about that, Femi. I'm so sorry. Okay, I'll back now. I'm back now. Yeah, we're back. Test 2. Yeah, test 2. Sorry about that. Okay, so then we say here, sorry. And then we say, so we're gonna pass, sulfate, okay. So then we're gonna pass through there. You add water chloric acid to this part and the filter if it's necessary. 3 drops of barium chloride, 3 drops. And then to clear this, so if you add hydrochloric acid, means it clear the solution. Hydrochloric acid, why? To filter to this party, okay, 5 milliliters of hydrochloric acid to this party, and then filter if it's necessary, and then you add 3 drops of barium chloride solution to clear the solution. Okay, so we see it's going to clear the solution, barium chloride. Now, this is going to be also our equation here, SO4 plus barium chloride, and this barium is going to take sulfate. Barium is going to take this sulfate, and then if barium takes sulfate, means you left only with a chloride ion. See what I'm saying? That's it. But chloride there 2, so I can simply say here 2 to balance. Barium is 1, sulfate is 1, sulfate is 1. Balance already. Okay. Now let's go to test 3. So test 3 also you can read. It's just simple steps here. Testing for iodide or chloride ion. So what you do, add 5 milliliters of anion solution, and then add nitric acid. Add your nitric acid to the solution. Boil it. We're gonna have to boil. Yes, until it's half what it was. So boil until it's a half of how it was, and then gently smell the gas that boiling off. You're gonna be in trouble. Don't just gentle, so you can feel that smell. And then add 1 drop of what? Of silver nitrate. We got silver and nitrate. Silver nitrate. So silver nitrate, look, nitrate is the radical which has a -1, and silver is a transitional metal which has a valence of +1. So when you cross this, it's going to be silver and nitrate. Both of them, they have a 1-1, so it's not going to have an effect. It means one come here, one come there. Okay. So, and then after adding 1 drop of silver nitrate, then we're going to have this question right here. Let's see the question. They give iodide plus silver nitrate from plus nitric acid, and then you get that products. And this one also, you take the chloride ion plus nitric acid, and then this silver is going to take the chloride ion plus silver nitrate. So this is going to give us, look, this silver, this nitrate. Okay, so this silver is going to take the chloride. It's going to be silver and chloride, means this silver and chloride is going to be together, and then here we're going to be left with a nitrate. Negative. Okay, means this and this, they're going to be together, and then this is going to be alone. Okay, now let's go to the question now, because now we've been going through this experiment over and over, but I just want you to so that when you go to the question, then you know where this answer is going to be coming from. Now the first one, the first question. The first question they say here, okay, the following, okay, put your student number here, your surname, like me here. My surname is Nkosi, initial Mtwana, and another one called Mtwana Nkosi. Okay, nkosi nati on course. See, mtwana wabantu. So my initial, my surname mtwana wabantu, and my initial nkosi mtwana wabantu. Course, okay. Daily practical, you can write a lecture. You can write your lecture. Now let's go to the question here. So now let's say read the following. Okay, so we want to identify the anion. When we identify carbonate, we want to answer the following. When you identify the carbonate, observation after pipetting the gas that formed into the solution of barium oxide. Okay, what did we observe? Okay, so I'm going to tell you what did you observe here. So what we observe, excuse me, they say anion identify. When we identify carbonate, you see, we want to find the observation after the pipetting the gas that's formed into the solution. Okay, what did you observe? As far as my memory, I have the page, so I'll just drag here and then I can tell you when you form the carbonate, what did we observe together? Okay, because it's more the reference in this. Okay, there's no magic here. Okay, it's not like, oh, I'll work it out, come from, nah, it is. Okay, let's go. So now when we produce this carbonate here, look, when you produce this, what did you observe? We observe that there's a milk solution indication of what? Of carbonate ion. There's a milky solution. So you observe and so, oh, there's a kind of milky solution. And also the gas also, there was a milk what? These are some milky solution indicated. That's what you observe. But due to what? Due to the presence of what? Of carbonate ions. You see what I'm saying? And another thing, so let's come here. They say, excuse me, observation after the piping of the gas that formed into solution. So we observe that the milk, due to the presence of what of? So this could be the answer here. You see? Okay, now let's go to the next question. So they say you have to write the solution. So the equation, this is a question here. So write your question. And the milk is just because of these carbonate ions. You see what I'm saying? Okay, now let's go to the next question. And they write all this equation because now they say here, if we can look careful for the second party. Oh, sorry. They say write the reaction. That's what say for the reaction is this one here. This is a reaction here. They're looking for this one here. Okay, we're done. Let's go for the second party now. So for the second party, it's easy. What I'm going to do is a question. Can you see? It's very, very easy. Write the question we did already. This one we did already. Now we go for number 2. For number 2, let me drag up a little bit so you can see. Now you can see here. Oh yeah. So for number 2 here, they say a solution of calcium hydroxide is known as what? Is the clear lime water. Oh, so that's a calcium hydroxide. Okay, so they say filter the lime water, make sure that your reaction will work. Okay, so we filter so that you can make sure the reaction is going to work. Now identify sulfate. So we want to go to the question whereby our anions identify was what? Sulfate. What is the question? They say we want to observe after adding hydrochloric acid, then barium chloride. What happened? What did you observe? Observation after addition of hydrochloric acid, then barium chloride. Okay, so the observation, now we drag the same page back here and see when we added from sulfate dioxide, when you add the hydrochloric acid and barium chloride. Now we come back here. Wow, let me. Oh, I'm wrong. This is a wrong page here. I kind of dragged, my apology. This was the page for carbonate, okay? We don't need that one. We need what for sulfate for this case, because they say for sulfate here. You can look careful now for sulfate and what did you observe? So let me drag a page of the sulfate from the experiment. It's true, and barium chloride. So the same part. Observation addition of hydrochloric acid. So we want to see what did you observe. We observe the white precipitate indicate the sulfate ions. Okay, so it's going to be the presence of sulfate ions. Let me show here. So we're going to observe here. What we're going to observe is going to be this one here. You see the sulfate ions here? Let me drag up a little bit so you can see. We're going to observe this. What we're going to observe right here. See, sulfate ions, and this is the white precipitate, which indicate what the sulfate ions. So what you're going to observe is going to be what? White precipitate of sulfate ions. That's going to be the first answer. And then let's see how the question asks again. That's the first party. That's the answer for the first party. Okay, for the second party, they say reaction equation. Okay, then you can simply write this equation here, because the one what? The reaction equation. Reaction equation means that question of the XO4. That is, means you write this plus that equal to that and that one. Simple. And the white precipitate indicate the sulfate ions, means the sulfate ions will be white precipitate. Okay, we're done with that. Let's go to the last one. So for the last one here, okay. So look, before we finish up, right? If you first time and you never be here before I finish the last part, please come to my platform here, visit Mtwana and Kosi, subscribe here, man, because we got a lot of community stuff where we help the vulnerable people, homeless people, so that they can stand on their 2 feet. You know, I have a feeding program with little that I have, you know, I share with other people, you know, because that's how I was raised. You know, I was giving a lot, you know, for my growth. You know, I was taught the knowledge, you know, so I was also given the knowledge. Apart from giving knowledge, also I was one of those vulnerable people at some point in my life. So subscribe to Mtwana here. This is my channel, and you can see here, I got a lot of love for my brother and sister here, man. This is me right here in the community, and this is my brother and sister from different part of African continent, just to be specific, in KwaZulu-Natal. And this is me, Mtwana. Subscribe. Now let's finish the last part here quick. Okay, so please go to Mtwana and Kosi, subscribe to that platform where you can see what we do for the community. Okay, now let's come here. So then for the last one is very easy. Now they say, why is this necessary to the mixture to taste for sulfate ions? Okay, why is that necessary? The reason why is just because, see, I can just paste here and then you can simply get there, and so we can save time. You know, the reason why we do that is just because this is because they say, why is necessary to add hydrochloric acid? So you can see from beginning we add hydrochloric acid, because a white precipitate, you see, because the white, okay, I'll just press here so that you don't have to. Why we have to test the sulfate ions? See, the sample is identified with the hydrochloric acid test, because the carbonate ions also produce white precipitate, okay, with barium chloride solution. So for that case, now the acid, when it reacts with those carbonate ion presence, is going to remove them. See, so it's going to stop them from giving the false positive result. So that's going to be our answer, okay? You can simply write down, and that's easy, okay? You know what I'm saying? So we should explain why they take the sulfate ions, the sample hydrochloric acid phase test, because of that. If you don't want to do that, there's another similar answer also. They say because, also you can take that one, either of the two, you can simply write down, and then I can go to the calculation for the last part, okay? Because why we test for sulfate ion using hydrochloric acid? Because the white precipitate of barium sulfate ion is going to form if the sulfate ions are present. So the hydrochloric acid is added phase to remove any of the carbonate ions, see, that might be present. See, they will also produce what the white precipitate, giving the false positive results. So you can simply write down. You see what I'm saying? Okay, my goodness, I don't like to read. Like reading a book, I used to get, you know, we got corporal punishment in Africa, so sometimes I used to get that. Now, they say, what is the ion identified in a gas? So I guess I should just drag the same, and then we go to sulfate, right? The same page, so we can tell you which gas produced. Of course, this is, oh my god. Okay, they say here, when you add the hydrochloric acid sulfate ion, means the same previous page we had. So we want to know which gas. Okay, look. So this one here is sulfate ion, right? Okay, sulfate ion. Oh, wait, let's look up. For sulfate, yeah, for sulfate ions. For sulfate ions, we want to find out the which gas. So for sulfate ions, let me do this. Let's go to the previous page. I'll get it. Sulfate ions. So it's more the ions. Okay, sulfate ions. We want to know about which gas. So then we say simply, I have to read the question very, very careful here. They say anions identified. So anions identified, if you can look careful, it's going to be chloride. I can just paste the equation here so you can see what I put for you here. It's going to be chloride. You can come back. I'll take you back a little bit, man. These experiments, like I said, you need to do a lot of reference. So okay, let's come. I'll show you now for, yeah, this one right here. Got it. So if you can look careful here, they ask for anions which identify. So anions identified is very easy for me. Like I say, look, they say here, excuse me, anions identified. So anions identified when you add hydrochloric acid and sulfate ions. In sulfate ions, which I just copied for you here, right here, these are the anions identified. Which anions? Chloride ion and sulfate ions. So I'll say chloride ions and sulfate ions. Means you have a presence of sulfate ions. See? And then the sulfate ions indicate what? The white precipitate. Means sulfate ions, which is this. And for anions identified, is going to be chloride ions for both. See, sulfate ions, which is white precipitate, and chloride ions. Okay, so I'm going to say here, anions identified. It's going to be what? It's going to be chloride ion and also white precipitate. Now, let's go to the next one. Now, for the last one, when you add anions identified, okay, chloride, look. So here and then, okay, look, let me tell you something very, very critical. For the last experiment, let's just drag it so you can see what I mean. How did I know, before we drag, how did I know for the last one? For the last one now, look, for the last one where it involved silver nitrate, they say the anion identified is what is? Chloride ion. So the one which is identified is, see, this one, that's what they're talking about. At last, chloride ion, this is the one which is identified. So you write the one which is in the reactant, okay? So for that case now, even a previous question, anions identified, I'd rather say what? Just say chloride ion. No, sulfate ions, my Paul. Sulfate ions. Because if you look careful here, it's here. Oh, sorry. So this one here. So this amount of anions identified is going to be sulfate or sulfate ions. Now let's finish up here. The last one, let's say the reaction. No, observation after addition of nitrate. So we want to see after we add nitrate what happened. We also see the white precipitate of chloride ions. So we're going to say white precipitate of chloride ion, white precipitate of chloride ions, white precipitate of chloride ion. Okay, cool, we got it. And another things, they say reaction equation. I'll just paste here so you can see. I don't have to write over and over and over. I just write here. These are reaction equation here to talk about. See, it's a reaction equation. I'm gonna cycle so you can see the reaction equation. This one to talk about. To me, more specific, the second one. Always take the second one, but I write them both. But this is the equation they need. You can write both, but just know this is the equation they need. Let me see if you can see. Oh, you cannot see. Okay, so let me drag up a little bit. Okay, let me do this. And this chloride is a white precipitate that we observe, and the equation is this one right here. Look, you might be first time in this program. Please just come right here and turn on courses, subscribe to our program so you can see what we do for the community. This me right here when I was 4th grade, and this my mother and her friends when I was a baby, and this one right here is me when I was a baby. Man, I'm become like photographer now. This is me in a community work, and this is the army, and this is Transitional Academy. So you know, without further ado, so we can just hop here. Thanks a lot for your time, and I'm gonna see you soon. Peace. We out.